For this demo, we introduce the design and implementation of a mixed reality human-machine interface for 3D printer operation and management. The demo begins with the usage of the bed leveling wizard, which we have designed to help demonstrate the advantages of a mixed reality interface when interacting with 3D FDM printers. A QR code marker placed above every printer on the network is used to help distinguish this printer from other printers on the system and to properly place holograms in the real world. When the bed leveling process is initiated, the holographic client sends a request, including the identification info from the QR code marker, to a unified backend server, which then initiates the bed leveling process. When the bed leveling process is complete, the printer firmware uses the measurements from the auto bed leveling probe to determine the amounts by which each screw must be adjusted. The backend server then takes these amounts and forwards them to the holographic client, which displays a digital twin of the bed to help the user perform the adjustments. Next, the user is shown a configuration screen with details about the printer setup to be confirmed. This is used to ensure that the current configuration matches that of the digital model used to verify print compatibility and perform error detection on the unified server. The user is then shown a 3D print preview style menu where they can choose from available printable objects on the server which have been verified to be compatible with the current printer's configuration. Once the print is initiated, a status overlay is generated and the user is free to operate other printers on the network. To demonstrate this, we begin a print on another printer across the room. Once again, the user is asked to confirm that the parameters stored in the digital model of the printer match those of the physical printer. As we can see, a different set of models are available on this printer, as the unified server has filtered out only the models which have been sliced for this particular printer. To demonstrate the error detection capabilities of the system, the G-code of this particular model has been modified in a way that will cause the extruder temperature to drop as the print is underway. Similarly, the user is able to return to working with any other printer on the network once a print has been initiated, and the unified server will still monitor all printers for possible failures. When a failure is detected for any printer on the network, the user is notified and a graph of the most recent sensor data is anchored above the particular printer. The printer is then paused by the unified server, allowing the operator to investigate the possible failure and determine whether to resume the print or cancel it altogether.